Okay, before we jump back into it, are there any questions I can answer?
Well, I just wanted to let you know, we have a thing going on at 3:30.
Okay.
Probably for about 15 minutes.
Okay.
So if we could take our next break just slightly before 3:30, that would be fantastic.
Okay. Like just slightly like 3:20?
Yeah, 3:20, 3:25. 3:25. 3:25. It's a short walk for us.
Okay. Sounds good.
And then in terms of the questions, is it generally frowned upon to use local bean because you aren't implementing interfaces?
It depends who you talk to. How's that for an answer?
Well, how about if I'm talking to you?
The only time I would do it is if I have a singleton.
Okay. And is the only place where you're supposed to annotate whether it's stateless or stateful is in the implementation?
Nope, you can do it on the interface.
But you don't want to mix and match. You don't want to have a interface stateless and a implementation stateful, right?
Right.
Okay,
the implementation will the annotation on the implementation should override the one that you quote unquote inherit from the interface.
It's interesting. But generally you'd probably set up a process where you would do one or the other, not both, right?
Right. Yep. Yeah, I mean, that example where I've got a stateless in an interface and a stateful in a bean, that I would say that there's probably actually a design problem.
Right.
Because from a client access perspective, you could never have both. It would make no sense to have both.
Right.
What is more common is that I define maybe a local interface. I tag an interface with local, and then when I go to implement the bean, I add the @remote or the @web service to the implementation.
Some, inheriting, some could be remote, some could be local. They all inherit the same interface. That's kind of cool. Hey, Kelby.
Yes.
I don't know if you heard, but Best Western won the Best of the Web for our industry.
No, I did not. That's cool.
Yeah, our website is the fastest and most reliable of all the hotels in the world. So they're having a celebration in our courtyard here at 3:30.
Okay.
And I was wondering if we could take a 15-minute break at that time.
Yeah, I was given a heads up that we needed a break before then.
All right.
I didn't realize it was a celebration, though.
Yeah, it's a really big deal. It came from CompuWare, and it's a big trophy.
That's cool.
Yep. And one of the developers for it is in the room here, and we'll all be going out to the courtyard, and they'll make a little speech, give us some cake, so we can come back in and finish our EJB stuff, if that's okay with you.
Yeah, that's fine. That's fine.
Sounds great.
And we're hoping that the developer here makes a speech too.
We're going to make sure she does, actually. But speech.
That's funny.
All right.
Yep, no problem. All right, so if there aren't any other questions, let's jump forward. Session being lifecycle. The idea here is to understand how a session being transitions from that does not exist all the way through the destruction phase, and how we as developers can get notification from the container as it goes through those transitions. So we already know, I've said it probably 4 times now, we already know that I can't directly instantiate a bean. We know that the physical EJB instance is hidden from the client. We also know that the beans are instantiated on our behalf When we do some action, I use the terminology trigger before. So when we trigger some action, we talked about how stateless is, generally we talked about how session beans are created based on J and DI lookups or dependency injections. There's a little bit more detail here. Because stateless beans are shared across multiple different clients, that pooled mechanism, for example, the first lookup that I perform, if the stateless bean doesn't exist, it'll create it. Every subsequent lookup that I perform, or every subsequent lookup that a client performs, the container is going to try to reuse the pre-existing bean. If it can't reuse the pre-existing bean because it's locked based on a threaded access, the container might create a secondary. But generally we say once a stateless bean is created, it's not going to be recreated. Stateful beans, the thing to note here is that every time I do a J&DI lookup or every time I do a dependency injection, a new one's created. And then singleton beans are generally created by the container at application load. To give you a little bit more information, the container can adopt either an eager load strategy or a lazy load strategy. If it's an eager load strategy, the container is going to create the singletons directly on application initialization. If it's a lazy load strategy, the container is going to figure out based on runtime when to build a singleton. So kind of like with Hibernate or kind of like with some of the caching mechanisms out there, eager or lazy loading. From a destruction perspective, that's the opposite of, obviously, of the initialization. Once a bean has been destroyed, it's not going to, the bean itself is not going to come back into re-existence. There's no resurrection or reincarnation in the EJB world. If a bean did need to come into re-existence, what would happen is that the container would create a brand new instance from scratch. So obviously a new instance is going to have a different pointer in memory, so it's going to be a completely new object. The idea behind this destruction is that I, as a developer, even though there is a garbage collection mechanism that happens behind the scenes, I, as a developer, should clean up after myself. So whatever I initialize during my initialization process, I should deinitialize prior to destruction. So in between there, I have other potential lifecycle transitions. And remember, there are 3 different types of session beans. We got stateless, stateful, and singleton. This slide shows you the 5 potential transitions, but not every single session bean type is going to go through all 5. In particular, the only one that actually goes through all 5 is a stateful session bean. The thing to recognize here is that in the stateful session bean world, the way that we have described it, the way that other people will talk about it, is that stateful session beans in clients always have a one-to-one mapping. So one client per stateful instance. And things scale linearly. 1,000 clients, 1,000 instances. Some containers get smart, so to speak, and instead of creating a new instance for every new client, what can happen is that containers will reuse a stateful object. The way that they're going to reuse a stateful object is they're going to tell the object to take all of its internal states, all of its internal state data, and passivate it, serialize it is a more commonly used term, serialize it to disk or database or something. And then once the object has serialized itself, the container is going to clean it up, make the object look as if it's brand new, clean, empty object, and reuse it. And then when the client comes generally this happens because of client inactivity. When the client comes back and says, hey, I'm ready to use my stateful object again, the container is going to go grab a stateful instance that's empty, tell it to go basically reactivate itself, deserialize the contents, fill up the state data, and then the client will start working with it. So all that to say is that of the 5 lifecycle phases, the stateful is the only one that goes through all phases. And even in the stateful world, you may not experience a passivate and an activate if there isn't a lot of load placed on the server. So simplistically, here's a quick state chart, UML state chart for a stateless session bean. I've got 2 primary lifecycle transitions, post-construct. Post-construct is invoked after the constructor completes, assuming the constructor did not generate any exceptions. Pre-destroy is invoked prior to the object being destroyed, prior to the finalized method, if there is one, being executed. After the post-construct occurs and the business methods can execute, it's safe to say that all the dependency injection resources have been injected and initialized. Stateful session beans, we kind of just talked through the 5 different steps there. The post-construct is as the same as stateless. The pre-destroy is the same as the stateless. The pre-passivate and the post-activate, we described how the container can do that to support load, reusing objects to support load. The thing that we have not talked about is the idea of removal for stateful session beans. So remember that a stateful session bean is tied to a specific client, and it holds client data. Generally, the way that we would say it is that a stateful session bean is going to be around as long as the client session is valid. The easiest way for us generally to talk about a session is in the context of a shopping cart. So we would say a stateful session bean that represents a client shopping cart is around as long as the client is shopping. And then once the client checks out or once the client becomes inactive for a certain period of time, the shopping cart is gone. There is a way for us as a developer to notify the container when the container should start to perform the destruction process of a stateful session bean. So again, using the shopping cart analogy, I've loaded up my shopping cart with a lot of cool things. I'm ready to check out. I go through the checkout process, give Amazon my credit card. The credit card gets verified. Everything's fine. The transaction, the shopping cart checkout transaction completes. Now I need to tell Amazon to free up the cart. So from a development perspective, I would annotate a method on the EJB with the @remove. Let's call that method checkout. When I call checkout and the checkout method completes, then the bean will start to transition into this removal process, which means it's going to go through pre-destruction and then destruction. So long story short is that I can physically tell the container when to remove an instance as long as I create a method and annotate the method with the remove annotation. So here's a state chart to show you what that's going to look like for a stateful session bean. Again, pretty straightforward. It exists, goes through construction, it's ready, does business methods, under load or inactivity, goes to passivate, client comes back, becomes ready again, and then it eventually is destroyed. Last one, just for your knowledge, is the stateless session bean lifecycle. It's going to look exactly like, the singleton session bean lifecycle is going to look exactly like the stateless session bean. Has the same transitions, uses the same lifecycle annotations, so on and so forth. So those are the 3 different state charts for the 3 different types of beans. Let's talk about how to implement those. Again, in the EJB2.x world, I had to create a very specific method. The method had a naming convention that started off with the 3 letters EJB, all lowercase, and then the 4th letter would be uppercase, so like EJB passivate with a capital P, or EJB activate with a capital A. There was no interface that I physically had to implement to give me a compile time check that I had the method signatures correct, which made it a very brittle model. In EJB 3.0, the idea, again, was to move everything to annotations, or at least move as much as possible to annotations. And because of this annotation mechanism, I can abandon the EJB naming convention in 2.0 and use whatever method signature and whatever method name I want. The method signatures could be public, method signatures could be private, could be protected. It's really up to me on how I want to design my EJB. Obviously, if I create a public method and that public method is part of the interface, that means that it's kind of a dual-purpose method. It means that the container can use the method as a callback, but a client can also use the method to perform some business operations. So here's a very basic example where I've got this singleton bean. The singleton bean has 2 methods inside of it that function as these lifecycle callbacks. The first method here, post-construct, remember that's going to be invoked after the constructor completes. And you'll notice all that we do here is create an instance. Well, we just get the millisecond time, store it into a variable. After the post-construct completes, remember that now my bean is ready, so my add through divide can be invoked. And then at some point in time, this bean is going to be swapped out of memory. Easiest way, again, to describe that is application unload. And before the application unload actually occurs, the bean is going to be notified by the container through this pre-destroy annotation. And again, you'll notice in both of these, my access modifier is denoted as private. So those 2 methods are hidden from the caller, but still available to the container. Questions on that?
What happens if you have a return type and it returns null, or on a void it throws an exception?
Yeah, so return type isn't going to, I don't think you're going to get a compile time error on a return type. The container is not going to do anything with it. Exception, depending on the type of exception, it may be okay, or it may cause a bigger problem. If it's just like a general runtime exception, it could cause the container to completely bypass the entire destruction process, like on the context of a pre-destroy.
Okay.
So the general rule of thumb is make sure the code is robust enough that it's not going to throw an exception.
Okay.
Or if it does throw an exception, just make sure, like in the context of destruction, that the cleanup of the resource isn't a big deal. You know what I mean by that? So like if you had, like in this case, the singleton just has an instance variable, so if the destruction doesn't, a primitive instance variable, so if the destruction doesn't work properly, it's not a big deal because the 32-bit reference for that primitive is going to be garbage collected. But if it was, you know, a file handle to the file system or a physical database connection, it's a little bit more critical to make sure that cleanup happens properly. Other questions? So the other thing to be aware of is that I can stack multiple annotations up. So I could, this is a bad example, but I could, if I wanted to, put right above pre-destroy the word post-construct. So I could apply multiple lifecycle annotations to the same method if I wanted to. That's fine. And to take it one step further, I could, if this were a public method, I could add the @remove as well. Right, so I can stack. The point is, simplistically, the point is that I can add multiple lifecycle callback annotations to a single method. I don't need a one-to-one relationship. The primary reason that I point that out is again purely from a legacy perspective. EJB 2.0, EJB 2.1, there was a one-to-one relationship between lifecycle transition method, lifecycle transition, and implementation method. Any questions before we transition into message-driven beans? Okay. So message-driven beans. Message-driven beans, as a quick reminder, the intention there is to create reusable workflow.
Thank you. Please stand by.